Hello everyone, this is 𝐤𝐝 from Edureka, and the topic for today's discussion is the Google Cloud Storage. So without any further ado, let's go ahead and have a look at the agenda for today's session. So firstly, we'll understand what is Google Cloud Storage. Next, we'll learn why is Google Cloud Storage necessary and why is it used in the industry. Moving forward, we'll see the various cloud storage services which are offered by Google. And finally, we'll see a demo on each one of these storage services one by one. So let's understand what is Google Cloud Storage. Now, Google Cloud Storage is a set of various storage services offered by Google for different domain scenarios. It is a RESTful online file storage web service for storing and accessing data on the Google's infrastructure. Google Cloud Storage allows worldwide storage and retrieval of any amount of data at any time. You can use the cloud storage for a range of scenarios, including servicing website content, storing data for archival and disaster recovery, or distributing large data objects to users via direct download. So let's understand why we need Google Cloud Storage. First of all, it has a single API for all storage classes. The cloud storage's consistent API, latency, and speed across storage classes simplifies development integration and reduces code complexity. You can set custom policies to transition data seamlessly from one storage class to the next, depending on your cost and availability needs at the time. It is designed for 11 lines of durability. Google Cloud Storage is designed for 99.99 that are 11 nines annual durability. It stores the data redundantly with automatic checksum to ensure data integrity. With multi-regional storage, your data is maintained in geographically distinct locations. It is highly scalable and performant. Now, Google Cloud Storage is practically infinitely scalable. Whether you are supporting a small application or building a large exabyte scale system, Google Cloud Storage can handle anything. It is strongly consistent. When a write succeeds, the latest copy of the object is guaranteed to be returned to any get globally. Now coming to the zero carbon emission. You have many things to consider in the cloud platform you choose. First of all, it's the price, the security, the openness, and of course the products available. Now Google believes you should consider the environment too. A sustainable cloud is not only good for the environment but also good for your business. By moving storage from a self-managed data center to GCP, the emission directly associated with your company's data storage will be zero. Now here you can see we have certain users who use Google Cloud Platform for their storage services. We have Spotify, Coca-Cola, Evernote, Motorola, Philips, and many more. Now let's have a look at the various Google Cloud Storage services provided by Google. We have the Cloud Storage, we have Cloud SQL, next we have the Bigtable, the Cloud Datastore, and Cloud Spanner. We'll look into the details of each and every one of these services in this video. So let's get started with the cloud storage. Now, cloud storage is a scalable, fully managed, highly reliable, and cost-efficient object or blob store. It redefines what the industry can expect from online storage by providing a unified offering across the availability spectrum, from live data tapped by today's most demanding application to cloud archival solution, nearline and codeline. It has many features such as single API across storage, scalable to exabytes of data, very high availability across all storage classes. As we saw earlier that Spotify was one of the users of the Google Cloud Storage. Now Spotify uses Google Cloud Storage for storing and serving music. Using regional storage allowed them to run audio transcoding in Google's compute engine close to production storage. Now, working with cloud storage, there are two different methods. We have the console and we have the GSUtil tool. Now, console is provided by Google on the web page or the web UI itself, and GSUtil is a set of commands or tools which are used in the Cloud SDK. So let's go ahead and see how we can work with the Google Cloud Storage. First of all, you need to log in into your Google Cloud Platform account and you need to go to the console. In the left hand side in this toolbar, you can see we have the various services which are the compute, storage, networking, monitoring, and the development tools and the big data tools. So today we'll focus on the storage services. So let's go to the storage section. As you can see here, I have the option to create a bucket. So let's understand what is a bucket. The cloud storage lets you store unstructured data objects in containers which are known as buckets. You can serve static data directly from cloud storage, or you can use it to store data for other Google Cloud Platform services. So let's go ahead and create a bucket. So first we need to input the bucket name. Next we have to select the storage classes. Now there are 4 types of storage classes, which are multi-regional, regional, nearline and core-line. Out of these two, the multi-regional and regional are based on the geographic regions, whereas nearline and core-line are based upon the usage. Now multi-regional is used for the data which is accessed frequently around the world. Regional is used for the data which is accessed frequently in only one part of the world. Coming on to nearline and core-line, nearline is best suited for the data which is accessed less than once per month. That means you can access it maximum once per month. Now core-line is best used for the data which is accessed less than once per year. So now I'm going to select the regional storage class. Next we have to select the regional location and just tap on the create button. And within seconds your bucket will be created. As you can see that there is nothing inside this bucket here. You can directly drop your files here from your PC or your laptop, and you have the option to upload files, upload a folder or create a folder. Let me just upload one file. Within seconds the file is uploaded and it's shown here. Now that you have seen how to create a bucket and upload a file, the same can be implemented using the GSUtil commands. For that we need to download the Cloud SDK. Now Cloud SDK can be downloaded from Google. Tap on the first page and you'll be redirected to this page. Now you can install it for Windows, macOS, Linux or other operating systems. I have already downloaded, so I'll just fire up the Cloud SDK shell. Now just to create a bucket, all you need to do is type in the command GSUtil mb, which is make bucket, -c, which stands for the class, the storage class, which I'm going to select as regional, -l, which stands for location, and -p, which stands for the project ID. And finally you have to input the name of the bucket. For project ID you can refer to the my first project or whatever be your project. Just copy your ID from here, paste it, and then finally you need to input the name of the bucket. So now to list the buckets, all you need to type in is GSUtil ls. As you can see, we have 2 buckets, which is Edureka bucket and the Edureka bucket 2. The same will be reflected on the website itself. As you can see here, Edureka bucket 2 is also here. Now to list the contents of a bucket, you need to tap in the commands GSUtil ls -r and the name of the bucket. So as you guys saw earlier that I uploaded an image to the first bucket which I created, Edureka bucket. So let me list the contents of that one. As you can see, it's showing me the image which I uploaded. Now to delete a bucket, we have an easy command of GSUtil rm-r and the name of the bucket. Here I'm deleting the second bucket I created, and after that we'll list the buckets to see whether it was deleted or not. The same will be reflected on the website. Let me refresh this page. As you can see, we have only one bucket, which is the Edureka bucket. So now let's go ahead with Cloud SQL. Now Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage and administer your relational, MySQL or PostgreSQL database in the cloud. Now Cloud SQL offers high performance, scalability and convenience. Hosted on the Google Cloud Platform, the Cloud SQL provides a database infrastructure for application running anywhere. It is fully managed PostgreSQL database service and MySQL database service. The data is encrypted when stored in the database table. Now, Cloud SQL can be integrated with other services such as App Engine, the Compute Engine, and external services via the external IP. Now let's go ahead and see how we can work with the Cloud SQL. Go to the taskbar on the left hand side, tap on the SQL button, and here you'll be asked to create an instance which will be our SQL instance. Just tap on the button. Here you have the option to choose between MySQL and PostgreSQL. The PostgreSQL is in beta format, so I'll select MySQL. Now there are two options. First, we have the first generation and the second generation. Now second generation has 7 times the throughput and 20 times the storage capacity than the first generation. It is less expensive and it supports MySQL 5.6 and 5.7. Now in order to create your SQL instance, all you need to provide is the instance ID and set a root password. So the instance ID here is Edureka SQL2 and the password. Now you need to select the region and the particular zone. And just tap on this create button and your SQL instance will be created within minutes. So now that our instance is created, let's go ahead and click on the instance ID. Now as you can see here, we have so many options like user, databases, authorization, SSL, backups, replicas, and operation. Now let's get to the user part. Here we can create a user account. By default we have a root user. So let's create a user. Just input your username and put in the password. And within seconds your user will be created. Now coming on to the database part, here we have the option to create a database. By default we have 3 databases, which are the information schema, MySQL, and the performance schema. Let me create a database employee. As you can see, creating a database is so easy. Now the database which we created and the instance we created can be accessed using the Google Cloud Shell as well as the Cloud SDK. So we'll see how we can access the same using the Cloud Shell. Now in order to connect your SQL instance to the Cloud Shell, all you need to type is 𝐸-𝐶L the name of the instance and your username. The instance name is Edureka SQL2 and the username is 𝐶L. As you can see, within minutes I was redirected to the MySQL shell of the instance. Now this MySQL shell works in the same way as any other MySQL. So let's first check the databases. So as you can see, we have the EMP database which I created just now. You can use this database and perform the same functions as a MySQL shell. Now coming back to our services, next we have the Cloud Bigtable. Now Cloud Bigtable is Google's NoSQL big data database service. It is the same database that provides many core Google services including search, analytics, maps, and Gmail. It provides massively scalable NoSQL database suitable for low latency and high throughput workloads. It integrates easily with popular big data tools like Hadoop and Spark, and it supports the open source industry-based standard HBase API. Now Cloud Bigtable is a great choice for both operational and analytical applications, including IoT, user analytics, and financial data analytics. You can use Bigtable as the storage engine for large-scale, low-latency applications as well as throughput-intensive data processing and analytics. Now, Bigtable provisions and scales to hundreds of petabytes automatically, and it can smoothly handle millions of operations per second. Changes to the deployment configuration are immediate, so there is no downtime during the reconfiguration. Cloud Bigtable stores data in tables, which contains row. Each row is identified by a row key. It is the same as any NoSQL database. Now data in a row is organized into column families or groups of columns. A column qualifier identifies a single column within a column family. A cell is the intersection of a row and a column, and each cell can contain multiple versions of a value. Now working with Cloud Bigtable, there are two ways. We have the HBase, which is the shell-based tool, and we have CBT, which is the command line tool written in Go. Now let's go ahead and see how we can work with Cloud Bigtable. Just go to the storage section, click on Bigtable, and here you have the option to create an instance. Just tap on that button, and here you can see you have to provide your instance name. Instance ID is automatically created. Now you have the instance type, which is either production or development. Now production is not preferred unless and until you have a very high availability requirement with a minimum number of 3 nodes, plus it cannot be downgraded. Now development seems to be the best choice if you want a low cost instance for development and testing, though it does not provide high availability, but it can be upgraded to production later. Now we need to select the zone. you have to select the storage type, which can be either SSD or SDD. Now SSD has a lower latency and higher read QPS, which is query per second. Just tap on the create button and within seconds your instance will be created. So guys, as you can see here that I have created an instance which is Edureka-BT, the Bigtable instance. Now let's go ahead and fire up this instance using the Cloud Shell. First of all, we need to enable the APIs, which is the Cloud Bigtable API and the Cloud Bigtable Admin API. For that, we need to select the project here. Let me select my project. Now the APIs are enabled and I've created the instance. All we need to do is open the Cloud Shell now. So guys, as you can see here, it automatically connects to the GitHub repository of the Google Cloud Platform. And now to connect our project to the Google Cloud Platform, all we need to do is type in the command gcloud-config set project and the project ID. Let me just copy the project ID. And now to start the H-based shell, we need to type in the command quickstart.sh. As you can see, it throws an error that you cannot perform this action because you don't have the permission to modify the Google Cloud SDK installation directory. But instead, they rerun the command with sudo. As you can see, it is scanning for the projects and downloading the projects from the Maven repository. It's building the quick start with the snapshots. And in a moment, you'll be connected to the H-based shell. So guys, as you can see here, now that we have entered the H-based shell, now we need to create a table with a column family CF1. All we need to do is type in this command, create the name of the table, which is EMP, and the column family name. Now to list it, all we need to type is list, and it will list one row in the table EMP. Now to put the value of any value in a row R1, suppose, using the column family CF1 and the column qualifier C1, all we need to do is put in this command. The row number, which is R1, the column family, which is CF1, column qualifier C1, and the value to be inserted. First of all, I'll be inserting a value. Okay, now let's insert another value. And to see the values inside a particular table, all you need to do is type in the command scan and the table name. As you can see here, in the R1 row, let me put in another value in the row R2 and scan again. You'll see that we have two rows, each of which have the values. In the column family 1, we have the timestamp and the value written as Edureka GCP2. Now to drop the table, there are two commands to be inserted, which is disable the table name. I'll put in as disable EMP, and the second one is drop EMP. Now when I list the tables, it will show me 0 tables. So the same can be implemented via the CBT, which is the command line using the go command. So let's go back to our presentation. Now next we have the Cloud Datastore. The Cloud Datastore is a NoSQL document-oriented database built for automatic scaling, high performance, and ease of application development. Cloud Datastore features include automatic transaction, which implies that operations will either all succeed or none will occur. High availability of reads and writes, massive scalability and high performance, flexible storage and querying of data. We have the balance of strong and eventual consistency, encryption at rest. The Cloud Datastore automatically encrypts all the data before it is written to the disk and automatically decrypts the data when read by an authorized user. Now, Cloud Datastore is ideal for applications that rely on high availability structured data at scale. You can use the Cloud Datastore to store and query all types of data. You can use it for product catalogs that provide real-time inventory and product details for a retailer. User profiles that deliver a customized experience based on the user's past activities and preferences. The transactions based on asset properties, for example, transferring funds from one bank account to another. Now, data objects in Cloud Datastore are known as entities, and an entity has one or more named properties, each of which can have one or more values. Entities of the same kind do not need to have the same properties, and an entity's value for a given property do not need to be of the same data type. Cloud Datastore supports a variety of data types for property values. These include the integers, floating point number, strings, dates, and binary data. Each entity in the Cloud Datastore has a key that uniquely identifies it. The key consists of the following components. Let us see. So first, let's select a location. Now, entities are nothing but data objects in the Cloud Datastore, as I mentioned earlier. Now it is setting the region, and we'll have to input the following identifiers for a particular entity. We have the namespace of the entity, which allows it for multi-tenancy, the kind of the entity, which categorizes it for purposes of Cloud Datastore queries. We have an identifier for the individual entity, which can either be a key or an integer, an optional ancestor path locating the entity within the Cloud Datastore hierarchy. As you can see here, we have the namespace, the kind, the key identifier, and the properties to be added. So let's input the name. The kind I'm entering is a demo, which will easily help me categorize it for future purposes. Now, key identifier can be numeric ID or a custom name. Just tap on the create button. Now you have two options, which are query by kind or query by GQL. You can add properties such as, for the name, I'll enter type string. You can add another property. Just click on the save button. Now you have two options here, query by kind or query by GQL. You can filter the entities here, apply filter, which is the key ID is an integer equal to 500. Applying filters, you will get the following output. Now that we have seen Cloud Datastore, let's go ahead and have a look at the Cloud Spanner. Now, Cloud Spanner is a fully managed mission-critical relational database service that offers transactional consistency at a global scale, schemas, SQL, and automatic synchronous replication for high availability. Now, Cloud Spanner is the only enterprise-grade global distributed and strongly consistent database service built for the cloud specifically to combine the benefits of both relational database structures with the non-relational based horizontal scale. This combination delivers high-performance transactions and strong consistency across rows, regions, and continents with an industry-leading 99.99% availability SLA, no planned downtime, and enterprise-grade security. Now, as you can see here, the spanner gives a certain advantages over traditional relational database as well as traditional non-relational database. As you can see, in the traditional relational, we cannot have high availability as well as scalability. And in traditional non-relational, we cannot have a particular schema and we do not use SQL. But in Cloud Spanner, we have the benefits of both the traditional relational and the traditional non-relational. Now let's go ahead and work with Google Cloud Spanner. Just go to the spanner. It automatically enables the Cloud Spanner API for your project, so you do not have to do it manually. So now let's go ahead and create an instance. You can write the instance name. You can select the configuration of regional or multi-regional. You can select the number of nodes. Just tap on the create button and it will create a Cloud Spanner instance for you. So Spanner is very easy. You just need to tap on create database button and it will create a database. You can add a table. You can add columns here. You can also add columns here. So suppose you want to add the ID also. You can set the primary key. Just tap on the create button. And Spanner will automatically create the database for you. You can monitor your database or you can change the database. You can also query in a database. You can run a query from here or you can add it just by selecting the particular database and you can edit the schema. You can either add a column or delete a column, or you can add values. Now that we have seen the Cloud Spanner, here are some other useful cloud storage options. We have the persistent disk, Cloud BigQuery, and the Google Drive. Now, persistent disk is a high-performance block storage service suitable for virtual machines and container storage. It offers unmatched price to performance ratio. You only pay for the capacity and you are never charged for the provisioned IOPS. Additionally, persistent disk offers multi-readers, mounts, and on-demand volume resizing to simplify operations. Now, BigQuery is Google's fully managed low-cost analytics data warehouse. It is serverless and there is no infrastructure to manage, no need to guess the needed capacity or over-provision, and you do not need a database administrator. You can focus on analyzing data to find meaningful insights. Now, finally, Google Drive is a collaborative space for storing, sharing, and editing files, including Google Docs, with a 15 GB of storage space available for free accounts. Now that we have seen all the services provided by GCP, let's see exactly where and when these services are being used. As different applications and workloads require different storage and database solutions, Google offers a full suite of industry-leading storage services that are price performant and meet your needs for structured, unstructured, transactional, and relational data. The image given here helps you identify the solutions that fit your scenarios, whether they are mobile application, hosting commercial software, data pipelines, or storing backups. Now you might be wondering what is Google Cloud Storage for Firebase. Now Firebase, mobile and web access to Google Cloud Storage with serverless third-party authentication and authorization. Now let us see when these storage are used and in which scenarios. First, if we want to store a blob type, we use the cloud storage to use images, pictures, videos, objects, and unstructured data. When we come to NoSQL, we have the Cloud Datastore and the Cloud Bigtable. Cloud Datastore is used for hierarchical data, and Cloud Bigtable is used for low latency read and write access and high throughput analytics. Coming to SQL, we have the Cloud SQL, which is the web framework for structured data, and Cloud Spanner, which is used for mission critical applications and high transactions. Now, cloud storage, the examples are storing and streaming multimedia, storing for data analytics load, and disaster recovery. Coming on to Cloud Datastore, it is used for user profiles, product catalogs, and game state. Now, Cloud Bigtable is used for IoT, finance, personalization, recommendation, monitoring, and graphs. Cloud SQL is used for blogs, content management, websites, business intelligence application, CRM, ERP, and e-commercial application. Coming on to Cloud Spanner, it is used for financial service which are mission critical, global supply chain, and retail. Now we are left with the persistent disk. And persistent disks are used for virtual machines to share read-only access data across VMs. It is used as a backup of running VMs. Now BigQuery is used for large data analytical reporting, data science and analysis, and big data processing using SQL. So guys, I hope you have enjoyed this session on the Google Cloud Storage and you might have a brief idea for the various storage services which were offered by Google. Thank you for listening to this video.